Hello, welcome, and thank you for choosing to learn with me today. So in today's video, we are going to look at the geometric or the exponential sequence. So the geometric or the exponential sequence is kind of different from the other two that we have looked at so far, which is the quadratic and the arithmetic sequence. So the main property that differentiates the geometric sequence from the other two is it has no common or constant difference, right? So it does not have the first nor the second common difference. So no matter how many times you can subtract the consecutive terms, you can never get the common difference, right? Instead, what it has is it has a common or constant ratio, right? So what this means is, as we were in the previous two other topics that we covered, when we wanted to get from T1 to T2 or from T2 to T3, right? What we did was to add or subtract the difference, right? But in this case, since we have a common or constant ratio, what we do to get from T1 to T2 or from T2 to T3 and so on, what we do is we multiply or divide by a constant ratio. You understand? So to get this common ratio, the general rule is the ratio is equal to Tn over Tn minus 1, right? What this means is if T2 is your Tn, then T1, if T2 is your Tn over there, then Tn minus 1 is T1, right? Because 2 minus 1 is equal to 1. So Tn minus 1 will be 2. All right, so let's talk about this common or constant ratio thing. All right, so remember, when we say it's something is constant or is common, we mean it does not change. So what this means is when we take the ratio by dividing T2 by T1, we should get the same ratio as when we divide any term, any consecutive terms, as in when we take T100 divided by T99. So we must get the same value of the ratio. It should not change, hence common or constant. Oh, sorry about that. Hence common or constant. So it should be the same or it should not change. That's what it means when we talk about this common or constant ratio. All right. So as always, every sequence has a general term, right? So in this case, the general term of a geometric sequence is Tn is equal to A times R to the power n minus 1, right? And in this case, the Tn does not change. The Tn is still the value of the term in a sequence, right? And A is also still the first term in the sequence, right? But now we have a new variable, and that new variable is R. This R is the ratio, is the common or constant ratio, and that ratio is found by dividing Tn by Tn minus 1, right? And n is also still the position of the sequence, right? So basically the only thing that changes here, we change from having a common or constant difference to having a common or constant ratio. That's the main idea with the geometric sequence. All right, now let's look at an example to try and enhance our understanding of the geometric sequence and its equation. All right, we say the equation of the general term of the geometric sequence was Tn is equal to AR time to the power n minus 1, right? Let's say we were given the sequence, the geometric sequence 5, 15, 45, 135, right? Let's determine A. What is A in this case? We said A is always the first term of the sequence. So in this case, our A is equal to 5, right? So what is R? Remember we said R was equal to T2 over T1, also equal to T3 over T2, right? So on and so on. And we said in general, this was Tn divided by Tn minus 1. Okay, so in this case, let's use any term that we are given here. Let's use T3 divided by T2, right? T3 divided by T2, which is equal to 45 divided by, sorry, 45 divided by 15. All right, so we get a 3. So we would get the same value if we divided T2 by T1 because it's a constant or a common ratio. All right, so our general equation now becomes Tn is equal to A. What is our A? Our A is 5 times what? Times the constant ratio. What is our constant ratio? Our constant ratio is equal to N. Our constant ratio is equal to 3, and it is raised to n to the power minus 1, right? One warning that I need to give, that I feel is necessary for you to know, these two, you should not multiply them, right? Do not multiply the two, because when you multiply out the two, this is what you will get. You will get 5 times 3, which is a 15 to the power n minus 1, which is wrong. It's incorrect because this n to the power, this 3 to the power n minus 1. Okay, because this n minus 1 is a power of the constant ratio and not a, right? Please do not multiply out those two, all right? So let's move on to our next example. So in this example, we are given the sequence 1, 2 over 3, 4 over 9, and part A asks us to determine the next two terms, right? So what I would advise you to do always when you get such a question, when you are asked to determine the following terms, right? So is always find the constant ratio, right? The constant or common ratio. And remember, we do that by dividing T2 over T1 or T3 by T2, or in general, or in general to divide Tn over Tn minus 1. All right, so in this case, let's do that right away. Let's use T2 and T1 because it's simpler in that way. So we get R is equal to T2. What is the value of T2? That's 2 over 3 divided by 1, which remains 2 over 3, right? So this is our common ratio. So what you can do here, you can use this 2 over 3 to find the next two terms, because remember, to get the next term, you always multiply the preceding term by the common ratio, right? Or you could take this R and find your general term, which is AR n minus to the power n minus 1, right? And our A in this case is 1, and our R in this case is 2 over 3, right? Which is determine that 2 over 3, and all to the power n minus 1. All right, so our general term is 2 over 3 to the power n minus 1. All right, So now what we can do, let's find T4 because we're given T1 up to T3, right? So let's find our T4. So our T4 is equal to 2 over 3 to the power 4 minus 1, right? The value of n is 4, right? So this simplifies to 2 over 3 to the power 3, right? And that simplifies further to 8 over 27, if I'm not mistaken. Yeah, that's 8 over 27, right? All right, and our T5, let's find our T5. Our T5 is equal to 2 over 3 to the power 5 minus 1, which is 2 over 3 to the power what? To the power 4, right? Which gives us 16 over 81, if I'm not mistaken. Yes, 16 over 81. All right, so we're pretty much done now with part A. Okay, let's go on and find part B, which says which term of the sequence, excuse my bad handwriting, I can't even see it myself. All right, which says which term of the sequence is equal to 32 over 243. Right, let's go on and do that. Part B, right? So here, this is what you should always ask yourself when you are given these. Ask yourself, what am I given, right? And what am I looking for? What am I asked to find, right? So here you are given 32 over 243, right? What is that? That's your Tn. Okay, so what are you looking for? You have, remember your equation is Tn is equal to AR to the power n minus 1. But we know the value of A is 1 and we know the value of R is 2 over 3, right? Which we found on the previous question, right? So we have our Tn. So the only thing that's missing is what is n. So we are looking for n in this case. So let's plug in our equation. So we have 32 over 243 is equal to, what is A? A is 1. It's unnecessary to write it. What is R? R is 2 over 3 and it's raised to n to the it's raised to n minus 1, right? All right, so what's next now? What we could do in this case is we could simplify, right? How do we simplify here? So to simplify this, you have to bring this part to its prime factors, right? And raise it to what? To an exponent, to a certain exponent. What you need to do is to change this in such a way that you have this, so that you have the common, you have the common base in order for you to equate what? To equate the powers. It's always the case. That's the law, according to the laws of exponents. All right. Or what you could alternatively do, you could use, I'm not going to use that in this example because we have not covered it in this channel, right? So you could use the laws of logarithms, right? Where you could take the logs of both sides and then solve them, right? Laws of log, and on the other side is going to be 2 over 3, and then you raise that to n minus 1, right? No, I'm sorry, I cannot write on that part. All right, so you get the idea though. All right, so let's continue doing this. Let's continue with our question. So we're gonna try to simplify this in terms of exponents and try to make the bases the same, right? All right, so you can see that here we can simplify 32 and bring it into an exponential form, and it will be 2 to the power 5. This gives you an idea that the denominator is also supposed to be 3, because we have 3 on the other side and we have 2 on the other side. All right, so what does this simplify to? 243 simplifies to, yes, that's 3 to the power 5. All right, and all that is equal to 2. You can distribute this exponent, 2 to the power n minus 1 over 3 to the power n minus 1. All right, so remember, this was like this, and we were able to distribute it into this, right? So we need to reverse the idea. So the main idea, the entire reason why I did this, as in break it down and distribute it, was to show you that, to remind you of the laws of exponents, where that you have, which says that if you have two different bases but raised to the same exponent, you can take out the exponent, right, and raise the two different bases into the same exponent. All right, let's do that. So in this case, we have our base is 2 and 2 over 3, and we can raise that to what? To 5, and equate that to this. We do the same thing that we did with this one here. We do this. All right, we take 2 over 3 and raise it to n minus 1. All right, so now you can see that what we have now, we have the same bases but different exponents. So if we have the same bases and they have a certain exponent, in order for those numbers to be equal, the only way they can be equal is that the exponents are equal, right? You get it? So what I'm basically saying is, if I have 2 to the power 4 is equal to a to the power 4, this can only mean that this is 2 also. So this is the same idea. That means if I have 2 to the power 4 is equal to 2 to the power a, this simply means that these exponents are equal. So there's only one exponent that can make this number here 16, because 2 to the power 4 is 16, right? You get it? I hope you get the idea. Okay, so let's come back to our original question here. Let's put this aside just to remind yourself. Okay, so for you to get the idea, so what we need to do now is to equate the exponents, and that's going to be, let's say, I'm just going to write n to the other side, on the other side. All right, so that's going to be n minus 1 is equal to what? Is equal to 5. All right, then it's an easy algebra now at this point. So n is equal to 5 plus 1. All right, n is equal to 6. Then we're done. We have found the term that is equal to 32 over 243. So that's what was asked of you to do. All right, so in this example now, we are given the some information about the geometric sequence, right? We are given that the geometric sequence has a fifth term, which is equal to 80, right? And this geometric sequence has a common ratio of -2, right? And we are asked to determine the first 3 terms of the sequence. All right, let's do that right away. All right, so what do we know? Let's put down, what are we given? As always, I said we always ask ourselves, what are we given? What are we looking for? We are given T5, and we are told that T5 is equal to 80. And we are also given R is equal to -2, right? You get it? So remember, we know our general term, Tn is equal to A times r to the power n minus 1. Right, great. So now we have t5, but we have t5, we have the ratio, but we don't know a. So we can use that idea because we know that t5 is equal to a r times 5 minus 1, which is equal to a r 4 to the power 4, right? So let's use that idea and the values that were given. All right, what is the value of t5? The value of t5 is given as 80, which is equal to, what is a? We do not know a, right? It's part of what do we want? It's part of the what do we want. All right, because we want the first 3 terms and we do not know a. All right, so what is our r, which is given? We given r is equal to -2, so we raise -2 to the power 4. All right, let's continue. So now I'm just going to rearrange in such a way that the unknowns are on the left hand side. All right, it just feels right in that way. All right, so this solves to a, it's actually 16a, right? Because -2 to the power 4 is equal to 16, right? So it solves to 16a, which is equal to 80. So now to solve for the value of a, we divide by 16 both sides. Right, what value do we get? We get a is equal to 5. All right, you get it. So remember, a is always the first term of the sequence. So this suggests that t1 is equal to 5. All right, so we have t1 now. We have t1, meaning we have a. So we can use our general term to find the other 2 remaining terms that we are asked to find. All right, so remember, we know our a now. Our a is 5 and our constant ratio is -2, right? And we raise that to n minus 1. All right, now we have a, which is t1, and what we are looking for is t2 and t3. All right, so our t2 in this case is going to be 5 times minus 2 to the power 2 minus 1, which is equal to 5 times minus 2 to the power 1, and that gives us a minus 10. All right, you get it. All right, what is our t3 now? Our t3 is going to be 5 times minus 2 to the power what? 3 minus 1, which is equal to 5 times minus 2 to the power 2, and that solves to 20, right? Because 2 squared is equal to 4. 4 times 5 is equal to 20. All right, so we are done. We're pretty much done. That's it. Very, very important to understand the question and understand your theory of whatever mathematical problem that you are given. Right, so in this case we used the ideas that we had discussed before about the general terms, about the geometric sequence or the exponential sequence. So yeah, thank you so much for watching, and please do come back for more, and please share the video, and don't forget to subscribe, like, and leave a comment down below.